Hello everyone. Today we are me, Harshbir, Alisha, and Max. We are going to present our assignment on peer-to-peer and client-server model and comparison. So I'm presenting our study on analyzing network traffic using Wireshark to compare peer-to-peer and client-server models. We'll explore how protocols like FTP and HTTP behave differently in each model and how Wireshark helps reveal performance and security characteristics. In this study, we use Wireshark to capture and analyze packets in both P2P and client-server networks. By applying protocols, filters, we analyze communication using HTTP and FTP. We discover how protocols control sessions, move data, and expose possible security risks. Our analysis highlighted difference in traffic patterns, helping us understand how each model perform under real conditions. So now, what is Wireshark? Sorry. Wireshark is a powerful packet analyzer that captures live network traffic. It allows us to monitor protocol behavior, communication flow, and network structure. In this project, we focused on identifying traffic patterns during file sharing and web access by filtering protocols like HTTP, FTP, and TCP. We evaluated system performance and identified vulnerabilities. In P2P models, we observed multiple peers acting as both clients and server. FTP sessions begin with the login commands followed by data transfer. We saw the TCP three-way handshake retransmissions and delays caused by peer availability. This model had bursted traffic, more connections, and variable latency due to peer activity. And on the other side, in the client server model, communication was more centralized and predictable. Clients send get requests and serves respond with the resources. Wireshark captured full TCP streams and showed retransmission during delays. This model shows better organization and scalability with easier monitoring. So now I'm going to do the quick comparison between P2P and client server. So firstly, um, PTP network is sorry. PTP networks are decentralized with multiple peers communicating across various ports. But the client server models and networks are centralized, focusing on single server. P2P had more dynamic, less predictable traffic, but the other side client server was not structured and easier to analyze. Wireshark helped identify protocols, behaviors, security weakness, and traffic differences. So the conclusion is like in P2P, FTP is common, but security risks like plain text credentials. In client server, HTTP is reliable and easier to manage. Wireshark provides to be an essential tool for capturing packets, analyzing protocol, and identifying performance issues. This study highlights the importance of protocol filters in network analysis and security auditing. Thank you.
Hello everyone, my name is Harshbir and our group today Alsiha is talking about the peer-to-peer versus client-server network design and Varsha case study. I'll be talking about the peer-to-peer P2P networks. First, let's define what a P2P network is. In a P2P setup or a peer-to-peer setup, there is no central server controlling everything. Instead, each device, called a node, can act as both a client and a server. So all devices can connect directly with each other to share files, resources, or even messages. This design makes P2P networks more flexible and cost effective for smaller teams or projects where a full server isn't needed. For example, popular applications like BitTorrent use P2P technology to share files across users. Next, we'll be talking about the uses of for P2P. Now, what are the common uses of P2P, you might think? Well, one of the most popular examples is file sharing. like how BitTorrent works. It allows users to download files from each other without a central hub. Another great use case is internal messaging systems within a small company. This can be super helpful for small teams that need quick communication but don't have the resources for a server-based system. Overall, P2P is cost-effective solution for simple collaboration, but it's not always the best fit for large-scale operations. As for security concerns in P2P, while P2P networks have their benefits, they also come with big security challenges. Since there's no central control, each device must handle its own security. That means that if that just one device has a weak password or outdated software, the whole network can be at risk. Plus, without a server, it's hard to manage backups or control who has access to what. Sensitive data can easily be leaked out, and it's tricky to make sure everyone is following the same security rules. So, while P2P networks can work well in small settings, their lack of control and security can become a problem for larger or more sensitive environments.
The definition of client server networks, whereby client server and architecture establishes a centralized server that manages and locates resources or services to multiple client devices. Clients send requests to the server, which processes and delivers the appropriate response, streamlining network functionalities. The other thing we're going to talk about is components of client server networks, whereby the key components include for client server include a centralized authentication server, web servers, and load balancers. Cloud storage solutions further enhance the network by providing scalable resources, access, and reliability. Last but not least, we're going to talk about security advantages of client server. Client server architecture enables centralized control, enhances security through robust access management and authentication. This structure allows for quicker updates and fast vulnerability.
Good morning, everyone. My name is Alisha Arora. Today, I will be presenting upon three major topics. So, first one being the protocol analysis in P2P and client server. So, let's now dive deeper into how protocols behave in both network models. In peer-to-peer networks, protocols such as TCP, BIT, BitTorrent, and GNutella are commonly used. While these allow for decentralized communication and data sharing, they often lack built in encryption. This can lead to significant security risk, especially when credentials or sensitive information are transitive in plain text. The lack of a central authority also makes it harder to enforce uniform security standards. That's why it's really important. On the other hand, if we talk about client server networks, typically, they rely on protocols such as HTTP, HTTPS, FTP, and DNS. These networks get benefits from centralized authentication and encryption protocols such as TLS. This helps to ensure data privacy and integrity. The centralized structure also allows administrators to manage permissions, enforce updates, and monitor traffic more effectively, which enhances overall network security. So now will be moving upon next slide and next topic, which is traffic comparison P2P versus client server. So if we now look at how traffic behaves in these two models, then first I'll be talking about P2P networks again and then the client server networks. So first and the foremost is P2P networks in which the traffic is distributed directly between peers. This means there is no central server in between them, which is handling requests, which allows for direct and sometimes faster data exchanges. However, it comes at a cost, scalability is limited, and the network depends heavily on each peer's availability. If a peer goes offline, and then the access to the data or services it was sharing could be lost. There are chances that it could be lost. So, if we talk about the second one, the client server network centralize traffic through dedicated servers. This setup supports higher scalability because resources can be added systematically, like balancing, but it also creates a single point of failure. If the server goes down or is overloaded, the entire network service can be disrupted. So, now moving on to the third slide, that is scalability and performance metrics. So finally, let's talk about scalability and performance. So client server networks are generally more scalable. They can be expanded horizontally by adding more servers and using load balancers to distribute the workload evenly so that each and every member gets equally work distributed. This allows for consistent user growth. Additionally, the use of cloud-based storage and services enhances performance by ensuring quick data access, backups, and redundancy. In contrast, if we talk about the P2P networks, struggle with structured scalability, performance can degrade as more users join, especially if peers have unequal bandwidth or resources, while decentralization offers resilience if it often lacks the ability to perform consistently and resources optimization that client server models can achieve through planned infrastructure. So that's all for today. That's all wanted to talk to you about. Thank you so much for listening us. Have a lovely day. Bye bye.